Okay, so this lab starts with a data set of a lot of online reviews for women's clothing. And if you download the file that's on D2L and open it in Excel, um, the first thing you'll notice is that it's going to be a fairly large file, so it might take a while to open. But I'm going to equip you with some keyboard shortcuts that can help you navigate around this. And keep in mind that the whole point of this exercise, that is when we when we look at descriptive statistics and visualizations like we do in this initial unit, what we're trying to do is get a handle on what this data set is telling us. Okay, so to start off with, just a couple of useful shortcuts here. If you're in the upper left corner here and you click Control and down, that will take you to the last row. So we can observe that this is 23,487 lines long, but so 86. So this is so this is a fairly big data set, and we're not going to get very far by simply trying to read these reviews or by brushing our eyes over them and just trying to get a sense of what people are saying. So we're going to attack this problem of comprehending what this data set is telling us through a couple of steps. And so I'm going to go ahead and calculate some of the descriptive statistics, and then I'm going to run you through the visualization exercise. And so hopefully this will give us a little bit better of a sense of how to go about attacking a data set like this. Okay, so the first thing I want to do is to just get a sense of well, before I get started, just to review some of the descriptive statistics, because we are going to generate some descriptive statistics. So we've got three rough categories of them. We want to know, the central tendency, that is, where does it tend to center itself? So we're looking at this column here, column K, and this is the star rating. Okay, so for example, this first one here, this is a certain clothing ID. This is the age of the person who wrote the review, and this is the actual text. And we are interested mostly in this rating over here. So this is a star rating anywhere from 1 to 5. Okay, so if we want to know something about what people are saying, how we're doing, how we're performing as a clothing manufacturer, we want to generate some statistics, and we're going to start with the central tendency. Okay, in addition to the central tendency, do people tend to say 3, or does it tend to be centered on 4 or higher, or so forth? So we'll look at some of those measures. We're also interested in variation, or also called dispersion. That is, how spread out are they? So they could be centered on 4, but are they mostly 3s, 4s, and 5s, or are they centered on 4, but do they vary all the way across from 1 to 5? And then finally, the shape. And the shape is going to tell us something about how imbalanced it is. So we're going to look at skew, left skew and right skew. Okay, so but before we go into these and actually look at Excel calculating those, let's just review what these are. Okay, I don't think I need to spend very much time on what exactly a mean is. It's just an average. Just a little bit of a notation issue here. When we are looking at the sample mean, and we're going to assume that this is a sample of public opinion, so or customer opinion, we denote the mean with an X bar. Okay, so that's X bar, that's our mean. And this Greek letter here is sigma, and this just means add up. So summation of all of the X sub i's, where I refers to the row number. Okay, so we've got 23,000 something rows. So this means, so add up whatever that star rating is from 1, in the first row, all the way up to the nth row, where n is our total sample size. Okay, so really all we're doing is just adding up all of the values and then dividing by the number of values. Okay, so this is the same average that you've been calculating since like middle school, but just take note of the notation, okay? So there's no need to be alarmed or disoriented by this summation. It just means add up all of the x's from the first row all the way up to the nth row, where n is, let's see, in our case, it's control down, so 23,487, okay? Or 86 because it starts counting at 2. Okay, so that's just the average. Now, the problem with the average, of course, is that it is sensitive to outliers. So oftentimes, if we have an extreme outlier, and this kind of gives you an example of what can go wrong. We could have a situation here where we've got a mean of 13, and in this case, we've got a mean that's 14. But this doesn't really give us an accurate picture of where the data is centered because we have this crazy outlier over here. And so sometimes the mean is not a very good descriptor of central tendency in the case of having extreme outliers. So in cases like this, we're going to use the median. And so values that tend to have extreme outliers, such as home values, tend to be expressed as median. So you often hear about the median home price in Radford, or the median home price in Christiansburg. The reason why it's a median is because they're, if most of the homes tend to be around 200,000, you're going to get a handful of them that are over $1 million. That's just the way real estate works, and it's the way a lot of data works. Okay, so in cases like this, we're going to use the median, where you just line up your values and then take the middle one. And if you have an even number, then you have to take the average of the two middle ones. Okay, so the other way of measuring central tendency is the mode, and that might be useful for discrete data like our star rating. We just want to know, well, what star rating was selected most often. Okay. Did people mostly say 3s, or did they mostly say 4s, or did they mostly say 5s? Okay, so in addition to the measures of central tendency, we are also interested in the dispersion of the data. And so we have a number of ways of understanding how spread out the data is also. The simplest is the range, which just is the maximum value minus the minimum. So if our values range from 1 to 5, then that means we have a range of 4, 5 minus 1. Okay, but the range doesn't give us the full picture because if we have an outlier on one side, then the range kind of gives an inflated notion of how varied the data actually is. Okay, so instead, we want to get a little bit more data, which we can get from the variance. And the variance, this might look a little bit daunting at first, but really all we're doing when we're calculating a variance is this expression here is looking at how far each x is, that is, in our case, the star rating, is from the mean. Okay, so we just figure out what that distance is, and then we square it. And the reason we square it is because some of these will be negative and some will be positive. And so when we add them up, we don't want them to be 0, so we square it, and we add up all the squared differences. And then we divide by n minus 1 instead of n for various statistical reasons. But this gives us the variance. And I just want to point out that the variance is denoted by s squared. Okay, that's just the way of expressing it. You're not supposed to square this. It's just s squared means variance. Okay, so as the values vary further around this mean, then this variance is going to be larger. Okay, so variance is great. Variance gives us a good sense of the dispersion, but the problem is because we have squared these distances, we have units that are kind of hard to interpret in the context of the problem that we're looking at. So in our example case, then we're looking at stars, and this difference is not going to be in units of stars, it's going to be in stars squared, which is kind of a weird thing, doesn't make any sense. So what we want to do is to get back to our original units is take the square root of this whole thing. And when we take the square root of the variance, we wind up getting the standard deviation. Okay, so the standard deviation is our way of understanding how dispersed the data is around the mean. Okay, and again, we see this this difference here quantifies the spread of each individual x from the mean. Okay, so standard deviation, that shouldn't be anything new there, just a little bit of a reminder. The only thing I want to hit before we go and actually look at these things is just a reminder of skew, and I cover this in another video, but just as a bit of a picture here to remind you, when the data tends to have a certain so if the data tends to have a median that is here under this big part of the bell curve, but we have a mean that's kind of pulled out to the left here, that indicates that we have this long tail. So what this would mean is that we have a large number of very, very small values that are pulling this average down, but this median is probably a better representation of how the distribution is centered. So in the case of a symmetric distribution, that means the mean and the median are the same. And if we have a right skew, this happens when we have a large number of these large values. So we've got this right tail that's pulling it way out here, and we've got a median that is smaller than the mean. Okay, so that's the theoretical background. So let's go ahead and take a look. Let's get some descriptive statistics of this data to start off with. So we'll start with, we just want to know the descriptive statistics of this rating. So I'm going to come to Data and Data Analysis and select Descriptive Statistics. And I'm going to click here. And now I'm going to use a selection shortcut because, again, there are 23,000 rows. I'm going to click on the top one and then do Shift and Control and down. And that will select all the way from row 2 to row 23,487. And I'm going to make sure that this Summary Statistics box is checked. So once I have that, I'll click OK. All right, so there we have our descriptive statistics of this data. So we know that the distribution of our ratings is above 4. Okay, so on average we have higher than 4. And it looks like the median is 5. So that means the middle value, if we line up all the 1s and 2s and 3s and 4s and 5s, is 5. So we have more than half of our ratings are 5s. Okay, and we see that the mode is 5. So the most frequently occurring rating is 5, and the middle value is 5, although we have a mean of 4.19. So what this tells me is that we must have a bunch of 1s and 2s that are pulling the average down, because we see that the mean is below the median here. So we've got a left skew. And this is borne out here in the fact that this skewness number is negative. Okay, and we see the range. Remember, that's just the max minus the minimum. And we actually have the minimum 1, maximum 5. And the standard deviation, notice that's only 1.1. So we can read this as saying, okay, so the mean number of stars is just over 4, and they tend to be fairly close to 4. They tend to be 4 plus or minus 1 star. Okay, so 95% of them, by the empirical rule, will be between 3 stars and 5 stars. Okay, assuming a normal distribution. Okay, so that's the summary statistics part of this. So what about the visualization? So the summary statistics gets us only so far. Let's see if we can understand this data a little bit better if we can generate some visuals. So the first thing we want to do is to aggregate. We want to know, well, how many 4s are there? And this will help us generate visualizations down the road. So let's go ahead and create a pivot table. And we do this by coming to Insert, Pivot Table. And this range here refers to the entire data set that you want to use. And by default, it's going to select all of your rows and all of your columns. and it looks like it did it cleanly here, so I'm just going to go ahead and click OK. Sometimes it doesn't, sometimes it's missing something and you get an error message, but those error messages usually result from a faulty selection. So we get this nice little wizard over here on the left that lets us decide how we're going to aggregate. And in this case, we want to put the ratings in a row. Okay, so this tells me, okay, I've got a row for 1s, 2s, 3s, 4s, and 5s stars. And I would like to have, in this column, the number of each of those that I have. And so this looks like it's putting in the sum. I don't want the sum. So this is 1 plus 1 plus 1 plus 1, and this is 5 plus 5 plus 5 plus 5, all the way up to here. That's not what we want. We don't want to add them up. We just want to count them. So I'm going to click on this little arrow here and change it to value field settings and change this to count. So it defaults to sum. Okay, so now this tells me how many of each of the stars I've got. I'm going to go ahead and sort this in descending order, so it'll make the Pareto chart fairly easy to create. I click somewhere in this column. You can't click on the column header, it turns out. You have to click in here. And if I come to data and click this Z to A arrow here, this will sort them in descending order. So I see that I have 13,000 fives, and then this is more than half. And we knew that because the median was 5, right? And we knew that there was going to be a long tail here because we had that left skew. Okay, so the descriptive stats gave us some, but this will help us visualize it a little bit better. I'm going to create the pie chart by selecting these values and then coming here to this on this insert ribbon. Over here on charts, there's the little pie chart, and I'll just select the first one. You can try fancier things, but this will do the trick. Okay, so that tells us that we have more than half 5s. Again, we knew that, but this kind of gives you a little bit of a visual to see how the star ratings are working out. Okay, I'm going to go ahead and put that next chart in there. I'm going to come here and do the bar chart. Okay, so this gives me another way of visualizing the same information. I see I have a very tall column here for 5s, and then it goes all the way down to 1. Okay. Well, so this helps. I mean, this gives us an idea, but practically speaking, this is really not enough information. What we might want to know is, well, what products are actually doing well? I see that we have a lot of, we have some 1s and we have some 2s. Do those tend to be a small number of products? And if so, are those something that we need to work on? So we would like to make this data a little more granular by including data about the type of product it is. And in this case, this is called class name. So class name, you may have noticed if you were browsing the data, class name has things like dresses, pants, what kind of garment it is. And it looks like there's a lot of overlap between that, and you can use either of these columns, so department or class name, either one. But if I come back here, so what I'm going to want to do is select back on the pivot table so that I get back here. So you notice if you have the visualization selected, you get a slightly different set of options here. It lets you drag things to different parts of the graph, but we really want to modify the pivot table. So I'm going to come back here and click on the pivot table, and then I'm going to come over and drag class name over to columns. Okay, and so this breaks down the star rating by the particular type of product. So here, for example, I see that in jackets, I have 451 5-star reviews, 118 4-star reviews, 35 1-star reviews, and so on and so forth. And that is captured in this. It's somewhat difficult to read, but as you can see, this breaks down each of the star ratings by which product is there. And so you can start to make out some patterns. Some of the easier ones to discern here are these two categories. I think this is dresses and let's say lounge. I think you can see that these two are kind of similar here for the 3 stars. So they have similar numbers of 3 stars, but this one way outpaces this one on 5 stars. So we know that our addresses, when they, our addresses tend to have a lot more, proportionally more 5-star reviews than this other category here. Okay, so there's lots of ways of slicing and dicing this information. We might want to do something like do a bar chart or do a pie chart that tells us proportionally which products tend to show up with 1 stars or 2 stars, and you can do that. You could yeah, what the heck, let's go ahead and do that. We just make a new pivot table, same set of data. This time let's pull class name as a row, and we'll pull rating as a column, and the count of the rating. Okay, so now this gives us some data that we can aggregate in a slightly different way. So for example, if I wanted to know, okay, so the 1-star reviews are here. Let's see how these are distributed. I'll come here to insert and do a pie chart, and I can see that for my 1-star reviews, they appear to be mostly dresses and whatever this gray category is here. We can expand this, expand the font of this a little bit better so we can see. It appears to be knits, so it looks like we have trouble with our dresses and our knits. So we can go, rating by rating and kind of see the breakdown. Probably it'd be more accurate to do the proportion. So, we might just have more dresses and knits here because we have more of those reviews. But so we would want to know, okay, so of the reviews, of the reviews for dresses, what percentage of those are 1 stars, and see if there's a difference. Okay, but so I really just wanted to give you a sense of how these things work together. In descriptive analytics, we use both descriptive statistics and visualizations that kind of give us a sense of a way of describing a data set. So we've got a pretty large set here, and it would take us a while to go through this, but these kinds of tools give us some understanding of how we're doing